Okay. This past week, we learned about what Avogadro's number was. We learned about the quantity, the mole, and we learned a few new different ways to find equalities. Yesterday, or depending on when you're watching this video, on Thursday, we learned how to find or how to get from moles of a compound to moles of an element using the subscripts and how you can use the subscripts in a chemical formula to get you some new equalities. We used water in our first example in class, so today I'm going to use quinine, which is C20H24N2O2, to show you just a few more options of how you can get equalities. With water, we only had two elements, so there was only two equalities. We're going to have four separate equalities in this compound. First thing to think about is whenever you get a problem, and we won't even start with the problem first, we're going to write all of our equalities first from here. But when you are working with these compounds, you just want to write out or find all of the equalities that you possibly can. We have four separate ones because we've got carbon, hydrogen, nitrogen, and oxygen. All of them, no matter what, are going to equal 1 mole of our compound, C20H24N2O2. So all of our equalities are going to start the same way. 1 mole of C20H24N2O2 is going to equal the different amounts of moles of each element. So let's go ahead and we'll just write that 4 times because it's going to be the same for both. Okay, now for each equality, I'm going to go ahead and finish the equality for each separate element. And remember, you just get these from the subscripts. So you've got a 20 next to carbon. So for every 1 mole of C20H24N2O2, you have 20 moles of carbon. For every mole of our compound, we've got 24 moles of hydrogen. For every mole of our compound, we have 2 moles of nitrogen. And for every mole of our compound, we've got 2 moles of oxygen. Okay, so now we have our 4 equalities. Now we could actually go ahead and use this to solve a problem. Now, if you look in your textbook, your classwork was always the even numbers, and this is number 7.7 in your textbook. So I'm going to do the first one with you, A, and then if you want some extra help or extra practice, you should continue with B, C, and D now that you have all of the equalities written out. So A in the textbook gives you quinine and then asks you, and I'll rewrite it. I'm going to go to the next page, a new page, just to give us some more space here. There we go. We've got our C20. I'm going to rewrite it so that it's easier. But A says how many moles of hydrogen are in 1.5 moles of quinine, which is just the name of that compound, C20H24N2O2. Now, still a unit conversion, so we're still going to follow the exact same steps that we learned from day one. First step, you're going to state the given and needed. So you're given 1.5 moles of quinine, which is the C20H24N2O2. Remember, you need to write that whole thing to get partial credit on a test or quiz. And then your needed is moles of hydrogen. Our plan is when we have to figure out how to solve our problem. Remember, we don't have a nice little chart anymore like we did for our basic unit conversions. So you have to remember that when you are given any type of compound, you can get from moles of an element to moles of a compound. So we're going to go from moles, and I'm just going to write a Q for quinine just to keep it a little bit neater on here. But from moles of quinine, you can go to moles of hydrogen in one step. The equality that you're going to need, we already wrote down. We know we have 4 separate equalities that we can get from our compound. We have to find which one has our given and our needed, which in this case is this equality right here, and that's the one we're going to use. We need both are given and needed in the equality. So you'd write your equality, 1 mole of quinine equals 24 moles of hydrogen. And now we can go ahead and set up and solve. When we set up, we know we always start with our given number. So you're going to start with the 1.5 moles of quinine. And we have one step, so we know we need one conversion factor. And by now we should know that if we want our moles of quinine to cancel out, we want to put that on the bottom. Which means 24 moles of hydrogen is going to go on top. Before we go ahead and plug it in the calculator, we'll take a look at our sig figs. Our moles to moles is exact because that comes from a definition from just the formula itself. So those aren't going to count towards our sig figs. We look at 1.5 moles. We've got 2 sig figs here, which means we know we're going to have 2 significant figures in our final answer. So now you would go ahead and take your calculators, even though this is not scientific notation, so you might not need your calculator, but you're going to go ahead and do 1.5 times 24 over 1. And the calculator is going to tell you 36. Now, when you look at that, that has 2 significant figures, so you do not have to do anything to it except add your units for full credit. So 36 moles of hydrogen is going to be your final answer, and your problem would be done. Okay, so your homework has both moles to particles, like yesterday's worksheet did, as well as the moles to moles. Just as a reminder, on Monday we have normal class, but then Tuesday is our next test. Monday morning and afternoon, as always, I have extra help. Today, this afternoon, if you're watching this or listening to this, I should say, on Friday during class, the extra help schedule is posted in the classroom as well as in Schoology, so you could take a look and see who is offering extra help this afternoon if you'd like to go then. Okay, thanks for watching. You will receive extra credit for watching the entire video if you made it through the entire video, and I hope you have a good weekend. Bye-bye.